Hi, my name is Jim Byrne, Principal Systems Engineer from Data Technologies, and today I'll be reviewing an R730 connected to an MD3460 to do some performance testing. And with that said, let's begin reviewing our environment. And the first thing we're going to do is take a look at the system configuration. And you'll see that we have a system running Windows Server 2012 R2. And we have two processors, 6 cores each, to give you a total of 12 cores on the box. It's an Intel Xenon 2620, 2.4 gigahertz, and we have 256 gigs of memory, and we're also running a 64-bit operating system. And what we're going to be doing is testing this system for a backup target, and we'll be using Commvault's software to test this, and specifically we'll be using their CV disk perf utility to do this. Okay, so the next thing I want to take a look at here is the MD3460, and we can use the PowerVault utility to do this. First we'll start with doing a review of the hardware, and what we have connected is a 3460. It's a 4U enclosure, and inside the 4U enclosure you have 5 drawers. They're like little pizza boxes, and they have 12 drives in each drawer. And you can see in each one of mine I have 6 drives for a total of 30 drives, which is plenty for my testing. And these gray drives you see here, those are hot spares. These silver drives are data disks that are in use. And then down below here, it's fairly easy to connect this thing up. You have 2 power controllers. They're redundant, so if you lose one of these, the box will keep right on going. And we have 2 controllers. And they have 2 SAS connections on each, so you could have a total of 4 SAS connections coming in here. And for my testing, I'm just connected here and here, so I have 2 connections coming, and that'll be clear when I review the disk groups. With that said, let's review the disk groups. Now, the way I configured this was I set up 2 disk groups, and they're both RAID 6. They have 14 disks in a group. So let's take a quick look, and I thought this was kind of neat when I first started using this tool. You can go through and look at the physical components that are within a disk group. So what they'll do is they draw a little picture of the drawers, and you can see the blue dots there, the disks I've picked on each drawer. You can see I just spread them across the drawers. And then when you get down to the controller, they'll show you what disks are going over what controller, and I have in each group half of the disks are on one controller and the other half are on the other controller, so I spread them out to even it out. So for example, for disk group 1 here, I have 5 virtual disks here and I have 5 virtual disks here, and should one of these paths go down, it'll just fail over to the other path. They do basically a preferred path, and if one goes down, it'll fail over to the other path. And pretty much the same setup for disk group 2. Again, it's RAID 6, 14 disks total. And you can see by the blue dots how I kind of just mapped this out. And down at the bottom here, again, you can see I'm using both SAS cables. I've got half my virtual disks here and the other half here. Now, once you create your disk groups, all you do is you go in here and you right-click and create your virtual disks. And what I did for my testing is I created 10 virtual disks per disk group, and they're 3 terabytes apiece. And they're all pretty much cookie cutter. They're all the same. So if you look through here, you'll see that they're all 3 terabyte, and they're all using a 512 KB segment size. And the reason for that is, again, this is going to be used for a backup target. So all the data hitting this is all large chunks of data. There will be no small I/O hitting this. So that's why everything is in large chunks to just get as much data written per I/O as possible. Okay, so that's enough of the MD3460. Let's go take a look at the operating system so you can see what this looks like. And what I've done here is I've set these up with 20 drives, starting with G all the way down to Z. And every one of them, you can see, are 3 terabytes. And I'm just going to open up one of these so you can see what it looks like inside. And I have a script that goes through and creates these little disk test directories where it's going to write some files and read some files. And each one of these directories will be mapped to one CV disk perf process. So let me go into the script, and this will all become clear to you. So here we have the disk perf process. And what I do here with this script is I can adjust my block size and my block count so that I can figure out how I want these blocks written to disk so I can get a good test. And I'm going to be doing 2 tests. I'll be doing a 64K block test, and I'll also be doing a 128K block size test. You know, in my travels with COMBOL, I've seen some people do 64K, but the default that they tell you is 128. Probably 90% of the people, that's what they use. So I'll be doing both of these tests so you can see them. And there wasn't a heck of a lot of difference between the two of them as far as performance is concerned. And so with each CV disk perf test, you'll be writing 10 files, thread count of 1, and for this particular test, it's going to be 64K times 16,384 blocks, which will give you a file size of 1 gig. Got 10 files, so that's 10 gig per thread. Now down here, you'll see all the mount paths I just showed you, all the way G, all the way to Z. And here's my prefix, which is DT for disk test. And as I run through this, down here you see I have a couple of for loops. The inner for loop goes through each mount point, so it's going to go through G, H, I, J, K, all the way through. And then down here you'll see I take this loop here, and as I'm creating my path, that's where you get DT1, DT2, DT3, DT4, DT5. And that's where each process will be writing out to. So when I execute this, you'll see 100 CV disk perfs run. So now with that said, I'd like to move on to the monitoring tools I'll be using. You'll see these running in my subsequent tests. What I'm going to do is I'm going to run these tests. There won't be any audio with them. You can just fast forward with YouTube and just go through them and look at them. But I'll just go over these tools real quick. First of all, let's take a look at the Dell PowerVault Performance tool. And they give you some graphs here that you can go through and collect data on the MD3460. The 2 parameters I'm looking at are IOs per second and megabytes per second. This is how fast you're going to be able to throw backup data at this thing. And one of the parameters, I was in here looking at the metrics I could grab, and the only thing I could grab was the sum of the current IO. That's the sum of the read and the writes. And that was the only thing that they had available in this tool, unfortunately. So I was kind of hoping I could get something that I could do the reads in one line and the writes in another, but I wasn't able to get it. So the way I'm able to work around that is when I run my test, let me go back to my script real quick because this is important. As I run each one of these, I put a small delay in here using ping. So in the beginning of the test, I'm going to be launching, one process after another with a 1 or 2 second delay between each one. And at the beginning of the test, you'll be doing 100% writes. Later, each thread, after it writes its first 10 files, it will start reading those files. So at some point during the test, you're going to start seeing the percentage of reads slowly start to increase, and it'll go from a percentage read in the beginning of 0 and go all the way to 100% at the end. So as you're going through the test, you can just slide through and see, how does the MD3460 work when it's 0% read? How does it work when it's 30% read? How about 40% read, 50% read, 70% read? So you'll get it all through the whole test. And what's kind of interesting is you'll notice that the MD3460 does a pretty good job keeping the sum of reads and writes pretty much constant the whole way through. You'll notice the graph over here, the megabytes per second. Over here, you'll notice this as it's running will just basically level out throughout the whole test pretty much. Now the other piece that I'm going to use here for gathering some metrics is this tool, and it's kind of cool. You can see here it says time monitored. You'll see me basically stop and start this about every minute, so you can see at that point in time for about a minute what is the percent read, what's the current I/O, what's the current megabytes per second, the average I/O, the average megabytes per second, that kind of thing. So you can get it minute by minute to see what's going on, and then up here while I'm running the test you'll see data being collected. Okay, what we're going to bring up here is this is the command prompt that I'll be running. You'll see the output of the script as it runs. You'll see the variables just get filled out. There'll actually be 100 of these when it runs. And last but not least is the resource monitor. And in here you'll see all of the CV disk processes run. So you'll have, this is what you'll be looking at in the subsequent test. There won't be any audio with it, but you can watch the IOs, megabytes per second. You'll see all the CV perf processes run here. You'll start to see, who's reading and who's writing. And you'll see these all run here and get launched. So with that said, I'm going to stop here, and we can proceed to our next two tests. The two tests you'll see me go in and I'll point it out in the script when I'm running it. We'll be running a test at 64 K blocks and another test at 128 K blocks. All right, thank you.